So the assignment was to write a class, to hold a coin, have an int as a variable, a single variable, to store whether it is heads or tails. I added in a couple extra methods as well. So let's talk about this. Public class coin. Coin is the name of my class. My data, my property or variable is called side. It is private and it's an int. So if you made your variable public, change it. It should be private. Nobody should have access to that information directly. Nobody should be able to change the state of the coin without using a flip method. That would open up opportunities for people to cheat, right? Somebody could get in there and say, oh, no, it's tails, just by changing the state of the coin directly rather than actually causing the coin to flip. Here's my constructor. I start it with side equal to 1. Whether that's heads or tails, that's entirely up to me. The user doesn't really need to know that sides equal to 1 means heads, or side equal to 0 means heads. All the user needs to see is heads and tails. That's entirely up to you. So each of you will probably have chosen, well, maybe half of you would have chosen 1, and half of you would have chosen 0. Then I wrote 2 additional methods. So this method is called an accessor, because it's accessing the information in the way that I want the user to see it. It's a two-string method. When the user calls to print out the coin, print C, or C.toString, whichever way you want to do it. Make this a little bit bigger so you can see it. Oh. There we go. Be bigger. So our print C.toString should print out the word heads or print out the word tails. So I put in an if statement there. If side equals 1, return heads as a string. If side equals tail 0, it'll return tails because that's the else. Notice this is public. It means everyone has access to it. The return type is string. It's not void. This will always be the declaration for the two-string method. Public string two-string with a lowercase t and a capital S. So I also built what's called a mutator method. A mutator method is a method that changes the properties / variables, whichever way you want to call it, of the class. So here I'm affecting whether or not it's heads or tails. I use a nice straightforward random value where I multiply by 2 and convert it to an int. So I'm really just doing between 0 and 1. And I'm going to store that inside, so it's either going to be 0 or 1. So this is mutating the value of a property. That's why it's called a mutator method. Java really doesn't care if you call it a mutator or call it an accessor, but that's the vocabulary we use when we're talking about building a class. We have mutators and we have accessors. Mutators change data, accessors access data. We don't want to give the users the ability to mutate data without our control. We want to make sure we dictate exactly how that happens. So it would be odd if we created this and they decide, oh, let's make it 3 instead of 0 or 1. That would really mess everything up. Nothing would work the way we had anticipated. So we want to control exactly what the user can do here. So when I go ahead and actually create some code in the driver method, my main class, I create an object called C. New creates and constructs the reference to an object using the coin constructor. It is of type coin. This is the constructor. This is the type. C is the object. New is the command that creates the reference to the new object, does the action. Then I'm going to print out the state of the coin. Then I'm going to set some variables here. And I'm going to run a nice little for loop that's going to flip the coin 500 times and print it out each time. Essentially, that science experiment that you did somewhere in 8th or 9th grade, where they had you test the probability, and it's the lovely experiment where we have 30 students flipping coins, and it sounds like it's raining quarters, and we just count how many heads and tails are. Well, the computer could do it for you, kind of. Remember we talked about randomness in the past, where computer values aren't actually random. They're pseudo-random. They need some type of seed to start them off, and if you have two computers with exactly the same seed, the same starting point, then they will produce exactly the same sequence of random numbers. So, is that random? It's the closest we can get into in a computer. So what they normally do is they pick some type of naturally randomly occurring event and make that the seed. Something that won't happen again. A unique seed value will produce a unique series of random numbers. So we could use, for example, the current time and date. Not going to happen again. Theoretically, right? Unless we go back in time, that would be weird. But the current time and date will not happen again. Or they'll use random noise. Like they'll open a signal channel that has nothing connected to it. It's like on your radio in your car, turning to a dial that doesn't have any music. I know it's hard to do that now. But we used to have radios that you have to tune in. Or television stations. Again, it's hard to do that now. But you used to have television stations where you could turn to a television station that's nothing's being broadcast. And you would get white, like it'd be fuzz. Well, that's random, naturally occurring random noise, and they can convert that to some type of number that ends up being the seed generator. So that's normally how they do that. They pull down a seed from some type of open signal that's getting no information, and they generate a random. So it's pretty close, because it is based on a random event. As long as you're starting with a random event, you could say it's a random number. If it's not, if you use the same seed, then it's not going to be random. You're going to end up with exactly the same set of numbers. Two computers starting with exactly the same seed will start with exactly the same set of numbers, going one after the other after the other. So when we run this, we can see that we have a certain number of heads, a certain number of tails. It's almost even, not exactly even. The more times that we run it, the closer we get to that 50%. And that's a whole talk we could have about probability and statistics, actual statistics versus theoretical. So we're going to talk more about this in the next video. So pause the video and we will, well, stop the video and we'll never stop coding.